Welcome to the class, dear students. We are in the applications of integrations. In the previous lectures, we have done the applications as to find out the areas, how we have used the integration techniques. The areas also in between two curves and the curve between the x-axis and the curve, and the area covered or area is bounded by the region which is from y-axis and the curve. And then to find out the volume which is being generated when a particular curve is being revolved around the x-axis and around the y-axis, some volume is being generated. Then how to calculate the volume by using the integration methods we have done, and how to find out the length of an arc by using the integration we have done. So now we are in the last application, which is in the work, which is the work. Now what do you mean by work actually? Some work is nothing but an activity, right, which requires some muscular or a mental effort. So now how to calculate the work? That means it can be done by two calculations. One is by constant force. Suppose if a force been applied towards a direction, then the work done is given by force into direction. Now the unit of work is what? Joules. And the unit of force is Newton. The next one is work done by a variable force. That means the variable, the force is been varying along the given direction x-axis. Let us say from x is equal to a to b, some point to the other point, it is been the force is been applied, suppose, and that force is a variable force. It is been varying from time to time. According to that rate of change we have to see. Then we are using the formula to find out the work done is given by, this is the direction towards the x-axis, and from x is equal to a to b, suppose, then the work is given by the formula integral a to b f of x dx. Now suppose if this f is given in newtons, the force is measured generally in newtons and x is in meters, then we measure the work in joules. Okay, suppose if the force is being measured in pounds and x is measured in meters, then our work is measured in foot per pound. So this is what the basics of work, how to calculate the work. Let us now do a problem now. The question is, find the work done find the work done by a force of f of x is 1 over x square newtons along the x-axis from x equal to 1 meter to x is equal to 10 meters. So how to solve this problem? So the work done by a force, what is the given force is 1 over x square newtons, and then along the x-axis, and what are the limits of x? The limits of x are given as from 1 meter to x is equal to 10 meters. Okay. So now our job is to find out the work. The work is given by integral a to b f of x dx. Now, what is this? Integral 1 to 10. What is f of x? It is 1 over x square dx. And that is integral 1 to 10 x power minus 2 dx. Let us solve this integral, which is x power minus 1 over minus 1 within the limits 1 to 10. So that is nothing but minus of 1 over x within the limits 1 to 10. So let us see what is the answer for this. The work is done by negative 1 over 10 minus 1. So that is negative 1 over 10 minus 1 is minus 9 over 10, which is equal to 0.9. So now this is 0.9 is what? Joules. Okay, the work done is measured as 0.9 joules. Okay, I hope you could understand how to find out the work done when a particular force is being applied towards the direction, and this is the limits of given as given as x is 1 to 10, and this is what the solution. Let us now go to the little more typical problem to understand, but you have to read the question, try to understand, and then we will go to the solving the problem. a leaky bucket is there, and which is of weight 5 pounds, is being lifted from ground into the air by pulling in 20 feet of rope at a constant speed. So this is what given. From where to now, the rope weighs 0.08 lb per feet. Now the bucket starts with 2 gallons of water. What do you mean by 2 gallons? Means it is, we have to change into the other units. What is the unit? It is the pounds. So 2 gallons is nothing but 16 pounds, okay, of water, and leaks at a constant rate. So it finishes draining just as it reaches the top. So the bucket is being lifted with a few amount of water. When it has reached the top, then totally it is drained. So now how much work is spent lifting the water alone and lifting the water and bucket together? So this is what the question. Let us now solve this by understanding first. Now the first question is, water alone we are going to lift. Okay. For this, the force required to lift the water, whatever the force to lift the water is always equal to the weight of the water, correct? Is equal to the weight of water. So the force applied to lift the water is equal to the weight of the water. Now which varies steadily from 16 to 0 lb. That means what? 2 gallons is equal to 2 gallons is nothing but 16 pounds. Okay. Now what is happening? This is been varying from 16 to 0 lb, you can say, over 20 feet height. So the leaky 5 pounds bucket is lifted from the ground and into the air by pulling into 20 feet of rope. So it is going in this direction, and the rope length is 20 feet. This is what 20 feet is given. And now the bucket is being lifted from which weight to which weight. That means from which distance, how much distance it is being covered, and off the ground the water weighs how much. So by using all these conditions, let us now consider the function as f of x is what now? It is given by 20 minus x. Suppose water, when the bucket is in x feet off the ground, let us say, okay, over 20 times of x 16, that is 16 is the 16 lbs is the weight of the bucket, okay, of the water, and then it leaks 16 into 20 minus x. So what it gives you is 16 times of 1 minus x over 20, correct? Now what is this x? We didn't mention, right? X is the x feet is when the bucket is x feet off the ground. X feet is the distance between the bucket and the ground. The bucket and the ground, that is what the distance. So 16 times of 1 minus x by 20. So what is this now? Is given by 16 minus how much it is? 4x by 5, correct? And this is what the pounds, this is what the force. Okay, what is the formula? We have done this one. W is equal to what? Work is given by force multiplied by the direction. Now what is the direction here? What is the force here? The work is given by the force is given by the function f of x is given by 16 multiplied by 20 minus x, because x feet is the distance and the total distance is 20 feet. From 20 feet, the x feet is the distance between the bucket and the ground. So 20 minus x over by 20, this is what changing, and the 16 times of this one. So this gives you the total force, how much is been applied. And now the work done, W is given by integral a to b f of x dx. Now he has given you that what is the distance from x is equal to what? Here 0 to 20, correct? So the limits are from 0 to 20. And then what is the function f of x is 16 minus 4x by 5 dx. Let us solve this integral now. That is given by 16 times of x minus 4 times of x square by 2 into 5 is 10. Now within the limits 0 to 20. Let us apply the upper limit. 16 times of 20 minus 0, which is 20, minus, I can cancel this, 2 2s and 2 5s. So it is 2 over 5 times of 20 square is 400 minus 0. So that is 320 minus, this is how much? 800 minus this one is 160. So it is 160. Now what is the measure here? Because it is been, distance is been measured in feet and the force is measured in pounds. Our work is measured in this much feet over 1 pound. So this is what the work done, water alone. Now coming to the second question. What is the second question? Lifting the water and bucket together. So when the water and bucket together it is being calculated. So how much weight it is? 5 into 20. That means what? How much distance it is? 100 feet per LB, which is being, the force is being applied. The work is to lift a 5 pounds of weight. And what is the distance? 20 feet. So therefore what it implies? It is 160 plus this 100, because water plus bucket. So that means it is how much? 260. 260 feet per LB is the force, is the work of the work is done to lift the bucket and the water with the bucket. Lift the water with the bucket. Water with the and bucket together, you can say. Water and bucket together, you can say. So this is what the way to calculate the problem when the force is being measured in the LBs and the distance is measured in feet. Suppose the work will be measured in feet per LB. So this is what the way to calculate. So with this we have completed all the applications. That is the second chapter, the applications of integration, area, volume, arc length and work we have done. With this I complete the sessions. Thank you so much.